All right, so we're going to finish up the rest of this lecture about data representation. That was, oops, these slides right here. We were at the very bottom, and we only have 2 slides left. So the first thing we want to do is figure out how many things can be stored in a byte. What is the maximum positive value that can be stored in a byte? And that is assuming that we're starting from 0. So scrolling back up, we can see that n bits make at most 2 to the n things. And let's figure out what we can do. So 1 byte can hold 8 bits, yeah? And that is 2 to the 8 things, right? So technically, if you just do the calculation, you'll end up with this. We'll say, can I just make this smaller? Yeah. 2 to the 8, well that is, I think it's 256. 2, 4, 8, 16, 32, 64, 128, 256. And if you see that, you might pick D. But the real answer is going to be C because we can start at 0. We have to start at 0. So remember that 8 bits. This is 1 byte, right? 1 byte. And we get this many options. 0, 0, 0, 0, 0, 0, 0, 0. That's the number 0. Then 1. Then all the way down to 1, 1, 1, 1, 1, 1, 1, 1. And if you're not sure what this is, well, it is 1, 0, 0, 1 and 8 zeros. This one is that, minus 1. Okay? Which happens to be 255. So the real answer is going to be C here. Okay? I'm going to circle that. And now, yeah, so let's talk about data types just for a little bit. We've talked about what a byte is. So 8 bits make a byte. I'll never really ever use this 16-bit half-word thing, but 30 bits is a word. People call it that. And so that means 16 bits is a half-word. 32 bits is a very normal thing. We're going to assume we have a 32-bit machine in this class. I'll just write this down. In this class, we'll assume we are using a 32-bit machine. This means that all of our addresses, which we'll talk about in the next lecture, or possibly the one after that, will take up 32 bits, which is 4 bytes. Okay? And we also have 64-bit machines, and a lot of things take up 64 bits. On a 64-bit machine, addresses take up that much space, but also 64 bits is 8 bytes, and that is how big a double is. The floating point type, the type double in C++ takes up 64 bits. And these are either called quads or double words. All right, and yeah, the type of a variable determines the exact representation. What that means is when you're using characters, remember that characters are just numbers. So char C equals, I don't know, the character A. And remember that this is in memory. This is storing 1 byte, but in that 1 byte it's storing a certain number. Let's figure out that number again by going to the table. It is storing the number 65. 65 in 1 byte. Okay, so that's what's happening there. So we call this a character. We say that it's A, but really we're storing 65. And yeah, the data type determines the number of bits used as well, because a character will take up just 1 byte, but an integer, which we'll find out later, takes up 32 bits, or 4 bytes, and a double takes up 8 bits, or 64 bits, which is 8 bytes. And yeah, that determines a lot of things, like how precise your doubles can be, how big your integers get to be, things like that. And so that brings us to the end of these slides. And the last thing that I want to do to just drive the algorithm for converting between bases home is to make our own base conversion program. So I'm going to make a new file called base conversion.cpp. And the idea is we're going to make a program that this program will convert between decimal to and a given base, which is between, let's say, 2 and 16. Okay, so that's what this program's going to do. It will take a decimal number from the command line and then output the converted number to cout. Okay, so let's include a few things. IOStream, because we want to output stuff. Namespace std for always. Do we need strings? We need cstdlib, definitely. Because we need a to I, because we're going to get command line arguments. So let's get the number from the command line. Int n equals a to I, argv1. Let's make sure that the user gave us enough arguments. Oops. If argc is it unequal to 2, we'll say cr need or usage. You should have called the program like this: argv0, which is the name of the program, and then space n. And then, I don't know, where n is a decimal number. Okay, so we'll do that, and then we'll return like 1 to stop the program because the user didn't enter enough for us. And otherwise, we'll continue, get a number, and then we'll convert it. So cout n converted to base. Oh, we need a base too, sorry. We need 3 arguments, n, b. And let's actually put this on 2 lines now. So number and b is a base between 2 and 16. Okay? Converted to base b, and we'll get the base in the second argument, is, and then we'll have like a convert to base function. Convert to base nb, new line. Okay, something like that. Let's make an empty convert to base function. So convert to base will be our function. It will be taking 2 integers, so int, number we want to convert, and the base we want to convert it to. So n is the number we want to convert, and b is the base we want to convert it to. And then this is going to actually need to return a string, because if we return a number and we print it out through cout, it will automatically convert it right back to a decimal number, which is not what we want. Okay, so we're going to return a string representation. Now let's just make an empty stub program right now that returns nothing, just to make sure that our program works. And let's now use a makefile. So we'll make a rule for base conversion. Base conversion. And let's just not use the .o right now. Let's just go in one big step down to the final program. We'll do g++-o, g++-o base conversion, then give the name of the file. All right, and yeah, that's that. I want to show default make rules in just a second as well. Oops, wrong program. So let's do make base conversion. And we will run this, assuming it eventually works. But okay, we have some errors first. Let's see. Oh, I forgot to say that this is going to be called B. That's useful. And that might make a lot of errors go away. Yes. All right. So now if I run this base conversion with not enough arguments, it'll say, you should have ran this as /base conversion nb, because argv of 0 is the name of the program, where n is a decimal number and b is a base between 2 and 16. Awesome. All right, so now all we really have to do is program this convert to base function. Okay. And so the idea is this. We're going to start out our number. It's a decimal number. We want to convert. We'll start out our number at like the empty string 0. So string result starts out being empty. And we're going to run the algorithm that we did in class. So the first thing we're going to do is modulo by the base to get the first digit, right? So repeatedly modulo and integer divide by the base, right? And we keep doing that while the number's not 0, right? While n is unequal to 0, because stopping when n becomes 0, all right? And so this actually isn't going to work when n is less than 0. Negative numbers aren't going to really make sense here, and then also the number 0 won't make sense because we'll just output like an empty string. And then once we're done, we're going to return the result string that we built up. So maybe we should like assert n is greater than 0 and b is between like 2 and 16. We'll include CAssert for that. All right. Okay, so I think we're good. So the first digit. Let's see how we want to do this. Int first current digit that we're working on is going to be n mod the base. All right. So get the rightmost digit, the current rightmost digit, doing that, and then shift the number so that we can get the next digits. And before that, we should also add the digit to the result string. And I think that is what we want to do. So shifting involves changing n equals n mod integer divide by the base. And then adding the digit to the resulting string is the interesting bit. So the idea is this. We want to add a character to the result. Result equals digit character plus whatever it was before. Okay? And we have to somehow convert this number that we had, this digit number, to a character, because if like for example, if current digit is like a 1, this should be a comment, then we need to add the character 1 to result. Okay, so we need to do something like that. And this is like an example, something like indented or something. There we go. Yeah, I like that. So the idea here is we're going to do some fancy math. So we're going to say char digit character equals whatever the current digit is. It depends on the base, actually, which is the issue. Let's do it like this for now, and we'll notice the problem later. So we'll say whatever it is character 0 plus current digit. And this will work for when our base is between 2 and 10. And the idea is if current digit is 1, and we add the number 1 to the character 0, and then if I go to the book, all the digits are arranged in order. So this is why this works. So, oops. All the digits are arranged in order in the ASCII table. 0 starts at, what number was that? 48. So, if I add the number 1 to the digit, or to the character 0, I will get 49, which is the character 1 that I wanted. Okay, so you can see that if the digit was now 2, we would add the number 2 to the digit 0, and we would get a good result. All right? And so in that case, I think this is a good starting point to run our program. And I want to show you just something before that. So if I can get rid of this rule from the make file actually, because there are default make rules. Technically, I can say make base conversion, and it will run a default rule that does exactly what we see below. All right. There are also default rules for .o files. So technically, I could say, instead of testshapes.o, I don't have to give any of these actually. So I really don't have to give the above or the below .o making rule, or any of the .o rules for that matter. And the default rule only works when there's only one file, when it's a .cpp file. It works because there's only one implementation file involved. So actually, to compile base conversion, I don't even need a make file. Oops, I do not want to open that. Please close, sorry. There we go. And I will say make base conversion, and even though there's not a make rule for base conversion, it will run a default one that does exactly what we want. Okay? All right, and it did the same thing. All right, /base conversion. And we need to give a number, like, I don't know, 40, 42, and maybe base 2. And let's see if we did it right. So 42 converted to base 2 is, let's go to Python and make sure it worked. 0b that. Yeah, okay, it's working. It's working just fine. Let's convert, I don't know, 25 to base 5. That should be 100. Yeah, okay, this is doing great. Now, the issue comes when we want to do hexadecimal. So like convert, I don't know, 255, which should be FF, to base 16. Question mark, because the 15 after the 0 is the question mark. So when we have a larger base, we need to start at A somehow when our digit is starting at 10, okay? So that's what we need to change. So if digit character is less than or equal to 9, or if current digit, sorry, we'll say that our digit character, oops, will be that. Otherwise, we need to start at A, right? And our digit character, let me put this in braces just because that's what I'm trying to convince you guys to do, equals A plus current digit, but minus 10 now, because of A, if the digit was 10, we wanted it to be A, and so we wanted it to be 0. So we'll subtract 10. And I think this should now work. So I'll run that default make rule to recompile. We'll say base conversion 25.5, make sure it still works normally, and then 255 to base 16, and now it's FF. 54, 53, 51, 50. Let's make sure it goes back to 9 by 249. F9, awesome. And this is all correct because if we go to Python, we say F9, or we could use lowercase F9, and it is actually 249. All right, so this file now, we made a convert to base function that did everything that we did on the board. It took this number that we wanted to convert and a base that we wanted to convert it to, between 2 and 16. And we built up a string that was the result of running that algorithm that we did on the board by repeatedly getting a digit and then making that into a character to put in our result string in the right spot. And then we divided using integer division n by b, so that we made n smaller, so that we can get the next digits out of it, just like we did on the board. And then we knew to stop because n happened to be 0 in the very end. And so I think with that, that is everything that we didn't get time for in lecture. And I will see you in the next lecture videos for next week's topics. So see you then.